Okay, team. So here are some AP level questions regarding derivatives and increasing and decreasing intervals and maxima and minima. So in this first one we have the graph of f prime, the derivative of f. So it's really important to like annotate these so I remember what I'm looking at. So f prime. So this is f prime. I'm going to write it again even though it says it right there. And we want to know what describes all relative extrema of f prime, of f rather, on the open interval AB. Okay, so AB is the whole graph. And relative extrema, remember, are where f prime changes signs. Okay, so let's look for those points. So we have 1, 2, 3. And remember, so f, if f has a maximum, the derivative is positive to the left, negative to the right. If f has a minimum, the derivative is negative to the left, positive to the right. Right? Okay, so this first point, the derivative is negative and then positive. So that is a minimum. Then the second point, the derivative is positive and then negative. So that is a max. And then another min here because the derivative is negative and then positive. So we have two minimums, one maximum. Let's find that one. That is choice A. Okay, so same idea as the delta math. We're just getting a bigger variety of questions to make things a little more interesting here. Moving on. This one looks scary. Like when I look at this chart, I'm like, I don't like the way this chart looks. But this is actually pretty easy. So the function g and its derivatives have the properties indicated in the table above. What is the smallest x rather at which g has a critical point? Okay, so critical point would be where the derivative is equal to 0. And that looks like as I go left to right. So the x's are up here. G prime is what I'm looking at, and that would be here. So that would be x equals 2. Okay. For the point in this one, is this a minimum or a maximum or neither? Well, the derivative goes from negative to positive, so that is a minimum. So for this one now, on what intervals is f increasing? So we have again a graph of f prime. So notice, like, if I thought this was a graph of f, I would get this one wrong. So we want positive derivative. So notice it's like the derivative is positive everywhere, except for this little chunk over here from 3 to 5. So we want to say from negative 2 all the way to 3. So negative 2, 3 is my solution there. Okay. Here, again, graph of f prime. And then tells us a bunch of stuff about the derivative that we actually don't really need to read in this case. On what intervals, if any, is f increasing? Okay. So f increasing means f prime is positive. And that is over here, right? So the interval would be from negative 3 to 2. Okay, cruising right along. So the derivative g prime of function g is continuous and has exactly 2 zeros. And then g prime is given in the table above. Okay, so here are 2 zeros, right, at negative 2 and 2. G is decreasing on which of the following intervals is what it's asking. So G is decreasing means G prime is negative. So that looks like from negative 2 to 2. Right? Only place that's negative. Okay. So these I don't think are super challenging. Just like remember your little list of rules that I gave you and you'll be okay. Okay, this is a scary looking one. So it's scary looking because our derivative that's given is scary looking. So what we want to know is when will what value of t will the pollutant be at a minimum? Okay, and what I will do here is I give you this hint, graph the derivative using a graphing tool, and remember what we're looking for at a minimum. Well, what we're looking for is the derivative, so p prime goes from negative to positive at a minimum. Okay, so, and it's going to be equal to 0. P prime is equal to 0, and it goes from negative to positive. Okay, so I'm going to graph it on my graphing calculator, and I've already typed it in. I'm going to hit graph, and notice, so I'm going to zoom in a little bit and show you what it looks like. So I'll give it a second to graph, and it's like hard to get my window exactly right. So I'm just gonna zoom standard, zoom 6 it, and notice it does not touch 0 in this window. So this is probably what you're gonna get if you graph it right off the bat. I'm gonna zoom out a little bit, and I'll leave it on the standard, and then it becomes hard to see, right? But what I can do is I can use the calculator to find that 0. You guys have done this before. So do second calc 0, and then it's going to be like left bound, and you can leave it on the x equals 0 because we're talking about days, right? So we don't care about the negative region at all. And then right bound, I'm just going to go to the right for a long time, and I'm going to watch my y, because notice my y is negative right now, and as I move to the right, it becomes positive eventually. So I know my intercept, my 0, is going to be somewhere in there, and that's going to be like yes, and I'm going to be like yes, enter, and I get 30.1. Okay, so, and it says round to 3 decimal places, so 30.174 is what I would say here, and that would be a t. Okay, so you can use a graphing calculator to tackle problems like these. We'll do a little bit more work on graphing calculators using derivatives over the next couple of months. Okay, just a couple more left. So this one, we have a particle moving along the x-axis. Its velocity is v of t. V of t is t ln t, so t times the natural log of t minus t, and then it tells us this nonsense that we don't really need. At what time does the minimum velocity occur? So we want v prime of t to be equal to 0, and we want the sign to be going from negative to positive at a minimum. Okay, so I'm going to take my derivative, and this is an interesting derivative. That's kind of why I put this one on here. Let me make my writing a little clearer here. So this derivative involves product rule and natural log, which we've seen a little bit, but we haven't run into a whole lot so far. So v prime of t, natural log of t. So the derivative of t is just 1, and then natural log of t is just chilling, so I'm doing product rule. And then the derivative of natural log is 1 over t. So I get 1 over t times t, and then minus 1, because the derivative of t is just 1. Okay? So now, this simplifies in an interesting way. So natural log of t is chilling, and then 1 over t times t, well, anything times its reciprocal is just 1, right? So plus 1, minus 1. These cancel, right? So ln of t, v prime of t. And now, this is interesting. So we want to set this equal to 0. And you're like, ln of t equals 0. So let's remember what that ln means, right? So ln is natural log. So that means that there's some number t that as a power of e gives me 0. So I can rewrite it. I can say or e to the 0 equals t is how I rewrite that as an exponential. Okay, and then it becomes, I think, suddenly easier if you remember your exponent rules. So anything to the 0 power, is 1. So t equals 1 here. So that is my t. And I have to make sure that the sign changes, right? So this is kind of a hard sign chart. So t equals 1. Well, let's see. So to get 0 is undefined, right? But if I say like 0.5 for t, that would have to be a negative exponent to give me that, right? Because like e is 2.71, so anything less than 2.71 would have to be a negative t, and then anything bigger would have to be a positive t. So negative to positive is what we want. T equals 1 is my solution here. Okay. So where I want you guys to be at, right, is you should be able to get to this point. Even though the derivative is a little bit challenging, if you got caught up on this, that's okay. Okay, but make sure like you understand how I did this before you move on. Okay, and that is it. So as always, remember to go back and rewatch if you get stuck and ask me for help if you still don't get it after watching the video.